You know, there's a technology we all trust every single day, but it has this critical weakness. We're going to dive into that, and then we'll look at the seriously clever fix for it.
Okay, so put yourself in this situation. You're the captain of this massive supply ship, right? And you've got to keep it perfectly still, just meters away from a billion-dollar offshore platform. I mean, there is absolutely zero room for error. Every single move you make is a massive risk.
So, for decades, what have we trusted? Satellite positioning, right? GPS. But here's the kicker. What if I told you that at the exact moment you need it the most, it just stops working reliably? It develops this huge blind spot. And this problem, well, it's got a name.
Yeah, it's a real problem, and in the marine industry, it is a huge deal. They call it the GPS blind spot.
This graph right here, it just lays it all out perfectly. See, these super accurate satellite systems, the fancy ones called DGNSS, they need a clear shot of the sky to work. But what happens when you get a vessel right up close to, say, an oil rig? Well, the rig itself literally blocks the signals. You can see right here on the graph, the accuracy just tanks. The very thing you're trying to get close to casts what's called a satellite shadow, and suddenly, your most important tool is useless.
So you gotta ask, right? How do you see inside that shadow? Well, turns out there's an answer. It's a system built specifically to work in the very places where GPS gives up, and it's called Radius.
Okay, so what is it? Put simply, Radius isn't trying to find its way from New York to London. That's not its job. Its only job is to know its exact distance and direction from one specific thing to another. Think of it like a specialist, and its specialty is making sure nothing bumps into anything else in really tight spots.
So the system has a few different looks, as you can see, but they all work on the same really smart idea. On your ship, you have a piece of gear called an interrogator. That's kind of the brains of the whole thing. And then on the platform or rig you're getting close to, you stick a transponder. It's basically a game of Marco Polo. The interrogator shouts a signal, and the transponder shouts it right back. Super simple, direct communication.
And what's the most important thing here? Reliability. This system is just built like a tank. It's solid state. What does that mean? No moving parts, no little motors, no spinning antennas, nothing that can just break down in the middle of a job. That's why it works no matter what. Brutal storms, extreme freezing cold, you name it. It's tough, doesn't need much looking after, and get this. Multiple ships can use the same transponders at the same time without messing each other up.
Okay, so it's tough, we get that. But how in the world is it so precise? Well, it's not magic. It comes down to two really cool pieces of tech.
First up is something called interferometry. I know it sounds super complicated, but the idea behind it is actually pretty beautiful.
Okay, so just picture a radio wave coming in from that transponder. See these two little antenna patches on the interrogator? That wave is going to hit one just a fraction of a second before it hits the other. We're talking a tiny, tiny difference. But by measuring that microscopic delay, the system can do the math and calculate the exact direction to the target. It's just pure physics at work. So cool.
All right, the second piece of the magic is the transponder ID. See, this thing isn't just a simple mirror bouncing a signal back. No way. When it sends that signal back, it actually embeds its own unique digital signature into it.
And this is a huge, huge deal for safety. Think about a regular radar. It can get confused by anything that reflects, right? A shipping container, a crane, some reflective tape. But Radius, it doesn't care about any of that. It's looking for one thing and one thing only, that unique digital ID. So it just completely ignores all the other junk, all the false echoes, and locks onto the right target every single time.
So that's how it works. Pretty clever, right? Now let's take a look at where this thing is an absolute game changer out in the real world.
First stop, offshore wind farms. You've got these service boats that have to park themselves right next to these enormous turbine towers to do maintenance. I mean, talk about a perfect example of a structure that creates a massive GPS shadow. Radius just steps in and gives them that rock-solid positioning they need.
Or how about this? Tandem loading for oil and gas. You've got a gigantic tanker trying to hook up to a floating production facility, and they're often doing this in rough seas. The distance and angle between these two monsters has to be perfect. Radius is what makes that whole dangerous dance possible. And then there are these crazy complex jobs, like laying giant pipes or cables on the seabed. You'll have one ship feeding cable to another, and they have to move together in perfect formation. If one of them is off by even a little bit, it could be a total disaster. Radius is what keeps them locked together, making sure the whole operation just works.
So, let's wrap this up. What is the big advantage here when you boil it all down?
I mean, this chart really just spells it out, doesn't it? Where the fancy satellite systems start to fail, Radius shines. When satellites get blocked by shadows, Radius doesn't even notice. And maybe the biggest thing of all, Radius knows exactly what it's looking at because of that special ID. GPS just gives you a dot on a map. It's a classic case of the right tool for a very, very high-stakes job.
And when we say accurate, how accurate are we talking? Get this, the stated accuracy is just 25 centimeters, a quarter of a meter. That's just incredible precision, and not in a lab, but out in the real world, in the rough conditions of the North Sea. Imagine the confidence that gives you as an operator.
And listen to this. This is from the actual vessel operators, the people who use this stuff every day. They say, unlike the satellite system, the signals are not masked when working close in. I mean, that's it right there. It works exactly where and when they need it to. It solves the exact problem we talked about at the very beginning.
So, next time you think about GPS and global navigation, maybe remember there are blind spots. And think about this. Our world is getting more and more automated, right? We're talking remote-controlled ships, robotic operations, all of it is on the horizon. And it's going to be these specialized, super tough, kind of invisible systems like Radius, quietly doing their job in the shadows that make sure all of it is safe. Makes you wonder, doesn't it? What other critical technologies are out there that we just never, ever think about?